I'm here to present is a brief of few of the projects that we've done using steel composite as a material. And my major part of the presentation would be on the structural aspects and what we've effectively tried to mold steel as a material. Having said that, the first premise that I also want to kind of take up and address is steel the only material? And a lot of times, we do have this significant debate that is steel the only material with which we can build fast, which probably has got the speed that the country needs. Well, to a certain degree, the answer is yes. We also do have precast, RCC as well, which does support this same ambition. But then there are certain inherent advantages and disadvantages to both the systems. So let me actually start first of all with a brief comparative on my perception of both steel and precast as a system, and then we get on to our different projects that we have done. So this basically is just a list of few of the steel composite projects that we've done. I've touched based on few of those in the earlier summit. Today I'll present a few more here. Yeah. So a brief comparison between steel composite versus precast RCC structures, and us as structural consultants or the contractors or the architects can always make an informed decision. And mind well, I am doing a lot of precast buildings as well, but I do have a little bit of a soft spot for steel, and probably the comparison kind of will take us there. So this particular analysis that we did was for a real-time project that we finished. Obviously, it's with respect to the speed of construction. What we have kind of found in that particular analysis for those couple of buildings was between precast and steel composite buildings itself, there was a significant reduction in terms of the timeline by almost 16%. And that goes to show, why a little, advantage the steel composite system do tend to have. It's pretty straightforward. It's obviously a much lighter system, but more importantly, we, as you can see in the image on the left side, we can have a multi-level construction happening in steel, while precast tends to. I mean, I wouldn't say that it necessarily only is the way, but generally what we found is single level construction happening in precast because obviously of the weight restrictions and the erection sequencing as well. What we've also kind of seen is that a lot of times, and both these images, what you see, the right one is for the precast, the left one is steel building with you can have eccentrically braced frames, you can have viscous dampers or yield restraint brakes as well as a lateral load carrying system, and eliminate shear walls entirely. Apologies. And so, again, even with those aspects, when you effectively kind of try to eliminate shear walls as much as you can, what you typically find in your precast or your RCC construction, you do tend to, expedite your execution speed. Obviously, this is again a comparative that I think most structural consultants would understand, appreciate that the only way to kind of resist. There are two ways to basically make structures earthquake resistance. One is to basically absorb energy. The second is to basically resist energy dissipated. I mean, given by the earthquake. In RCC, we generally tend to see that the energy is dissipated in the form of cracks in the shear walls. And then, in steel composite, should we choose to adopt a yield restraint break or a viscous dam building, we do have that option where, the absorption mechanism comes into place rather than resistance. Again, an added advantage to, steel composite versus precast, where the damage detection probably happens a little bit earlier as against, a reinforced concrete building, where the corrosion basically initiates and we tend to detect once the cracking actually starts. While in steel composite, obviously, if it's exposed, we do tend to get that advantage of, treating it earlier. Same way, even for maintenance and repair, I think this slide is self-explanatory. So if a steel member has been damaged by corrosion or by any which ways, then its capacity can be increased by adding a steel cover plate of appropriate size. Even that can be, repainted, retreated to enhance its capacity. While in, precast or other conventional RCC structure, we obviously tend to go with a much more rigorous approach. Floor space utilization index, I guess this is one of the better formed advantages that a lot of structural engineers tend to present to their developer friends and architectural friends. Yes, in one of the projects that we worked out, we've seen these deltas being between the column sizes, the delta being as high as 60%, and that's a significant increase in the usable or leasable carpet space for the same built up. Obviously, we do tend to see, steel largely being a fairly ductile material, we do tend to see a slightly better performance with respect to, the seismic behavior of the structures. Of course, connection being the most imperative entity on which the structural consultant tends to focus on while ensuring the seismic performance. Of course, with the lighter structure, the foundations do tend to get lighter. Now, I'll take you directly straight to the project that we've been very closely associated since 2020. It has gone through pandemic, and it's the Astronomy and Space Science Museum being built right here in Ahmedabad. It's supposed to be one of its kind, and these are few of the images, but it has a 30-meter dia dome, or should I say a globe, which is rested on 4 V-shaped columns. I&I Design Studio is the architect for that project, and we are the structural consultants. You see a sectional image for that. Yeah, and that's how basically the globe section truly looks like, where we have multi-level, platforms and some 4D, theater and experiences within that globe. Obviously, these are the Revit models of Revit model images of that same globe that we are talking about. That's the floor plan level on which we have the entire seating. And I'll take you, this obviously is under its, erection stage right now. And you see these are CFSTs that we've used, concrete filled steel tube columns. And as part of the fireproofing, these columns will be, painted by intumescent paint all across, and of course the rest of the steel girders that you see for the globe would be painted with vermiculite. That's another image where you see the ring beams all erected. There are 8 of them, and this was an earlier image where the first level platform for the services was when it was erected. And This is the recent image where the top ring beam was being lifted and put into place for the whole system to then come into, as you can see the proportion, there are two guys standing on top and the whole system coming into shape. Now of course the purlin works have, peripheral purlin works have initiated. These are few of the, obviously this posed a lot of challenge for us with respect to the connection design and the connection detailing, and there were just a few images. So yeah, that's the external side image. Actual photograph of the site. We have basically this whole globe is kind of enclosed within 40 meter by 40 meter space, where there are freestanding columns, as you can see, and then we have a space truss on top covering the entire globe, which would obviously be again spanning those entire 38-40 meters. We had a fairly large cantilever, probably I can show you right here. As you can see, it was about 8.5 meter cantilever, multi-level, and so we did use steel for that cantilever system as well, and that's how it actually has turned out. Now this is our sports complex, which is likely to be India's showcase project for the Olympics bid. And we have 4 stadiums in this project, block A, of course there are multiple buildings, but majorly 4 stadiums. And the 2 main stadiums where we've used steel is block A and block C, stadium A and stadium C. And stadium A is aquatic stadium and stadium C is indoor multi-sports arena. So in block A we have a steel roof dimension of 74 by 101 meters, and in block C, which is the indoor multi-sport arena, we have an 83 meter by 123 meter steel roof. Obviously this is all column free steel roof spans that we have done. This is basically the scheme that we've adopted for both the stadiums, and as you can see, it's a steel box section that's spanning all the way across, and then basically through a pull-up catenary action and an A-frame column on the edges, we are kind of pulling it back up.
2 minutes remaining.
Of course. So these are the images, and the fabrication is going on for this, and RCC construction is well on its way on site. These are the other, block B and block D, where again we have 25, 28, and 32 meter spans as well. This is the ground floor roof slab for the block C. Okay, since we have time shortage, I'll directly take you. This is a World Trade Center that we did for Brigade in Bangalore. This is a G+10, 2-basement ground plus 10 building, 45 meter in height, entirely in steel composite with RCC core. I won't take you through the different composite systems and the comparatives that we've done. Let me take you directly through the photograph. So yes, we've used circular concrete filled steel tubes. It was a G+10 building, spans ranging from 11 to 13 meters, floor to floor height being 4.05 meters, and as you can see, we had about 550 dia steel columns in the bottom, and going above we had 400 dia. So we had a fairly controlled sizing, of course, and that's the finished image. I mean, the building is obviously fully underused now, This was completed in 2022. And you see different connections, how they were actually developed. Inside, you see all the beams actually being covered with vermiculite and the columns being covered with intumescent paint. That's the expanse, and you see, services, being planned beautifully inside the structure with all the decided sleeves and cuts, embedded within the steel structure. You can see the expanse of the whole, spans close to 13 meters in this case, with just one central steel column right there. Again, just an image for everyone's understanding how services also can be beautifully integrated with these kind of steel structures. Yep. This is a last project. I'm sorry, my time is up, but this is a very interesting project. I'll take 1 minute. We are designing the media headquarters for Republic in Noida, and it's a 300,000 square feet project. Obviously, zone 4, importance factor 1.5. This project is designed by the Pritzker Prize winning, the only Indian Pritzker Prize winning architect, B.V. Doshi's office. Unfortunately, Doshi sir is not with us now. Obviously, the mandate from the client was, since it's a media house, we don't want to be in the zone of collapse prevention only, which is basically what IS 1893-2016 really states as a principle. We want to be in the operational to immediate occupancy category. So obviously, there was a significant level of discussion on, and obviously one of the more critical criteria for the client was he wanted to move into the building ASAP. He wanted to move into the building in about 11 to 12 months from the time the construction started. I'm not sure whether this can play. Can this play, or can we play this just for the audience's understanding on what we're talking about? If you can start both the slides simultaneously. So on the left side you see an undamped frame, and on the right side you see a damped frame being given the same level of frequency with respect to the and this basically is a seismic simulation, and how perhaps damper system may actually be an option that can be looked at, replacing the shear walls entirely for this particular project. Because of the time constraint, we obviously had to think out of the box. So this is basically the footprint. We ended up using yield restraint brake for this particular project. 34 YRBs were used, and these are the locations of those YRBs in the frame we have in this particular project. Of course, this is an entirely steel composite project, and we have spans ranging from 18 meters to 27 meters, multi-level of course, and these are studios, so obviously the studios tend to have fantastic heights too. I won't take you through this part because this will take a lot of time. But we did, undertake, MC level and DB level with R equal to 1 earthquake analysis as well, specifically for, ensuring that, the dampers are being designed to that particular level. Just an analytical result, by using these YRB dampers, we actually ended up dissipating 45% of the earthquake energy. And that was a massive gain. That we actually ended up achieving. Even with respect to the FEMA standards, we wanted to, of course, be in the immediate occupancy level. So right with R equal to 1 at the dB level, we had story drifts which were lesser than 0.5 and acceleration still lesser than 0.4 G. For the stroke lengths, obviously, we again refer to the MC level, so how the damper strokes really, get activated, and to what level do we need to ensure that each and every single, YRB is designed for, different strokes. We work that out. And these are few of the images of the construction. It's well underway. The YRB installation is going on as we speak today. And yeah, we have a very parametric skylight on this project as well. Just few of the other projects, including IIM Udaipur, that we had been part of, where a massive steel library, multi-storied, spanning 32 meters, was done. And that's how it actually looks. These are the erection photographs of how the whole, it was a verandial, system spanning 32 meters. Rashtriya Raksha University, again done entirely in steel with eccentrically braced frames. And even in that, the facade was actually fully developed with steel sections, as you can see. Yep, another project that we have done way back, but it's quite beautiful. And yeah, thank you so much.